Question, what exactly is an SDV? Well, that is a lot clearer now, but there's still a lot of wiggle room on the actual final definition. That brings us to an exciting new phase, which is answering these questions. How can the industry make SDVs a reality, and how can they be made more cost effective? And what steps are needed to be taken to rapidly and successfully bring them to market? Today, we are going to discuss the future of SDVs with this panel of 5 experts who are drawing a roadmap to the software-defined era. Thank you very much for joining us. I would like to introduce first Google Head of Automotive, Steve Busra, to my left. ARM Senior VP and GM Automotive Line Business, Dipti Vachani. Thank you very much for being here. Jeff, I'm sorry. I'm going to do the best I can. Sonatas. Yes? Okay. Sonatas CEO and founder Jeff Chow. BMW Senior VP Connected Company Development, Stefan Dorak. And Jürgen Reers, who is Accenture Senior Managing Director, Global Lead, Automotive and Mobility. And my co-host today, Jürgen, could you please start us off by outlining the framework for today's discussion?
Great. First of all, thank you very much for being here, Doug, and thanks for moderating our session. And welcome to all of you. So we talk about software-defined vehicle, but I actually like to talk about user-centric vehicles, right? Because the software-defined vehicle, and I think in terms of the technology, in terms of the setup, we are there now to enable all kinds of personalized user-centric services, create new digital services, and I think that really marks a new era for our industry. And I think we can see this here at IAA in a quite remarkable way, and it's also opened up a huge business opportunity. So we see the market to triple over the next 10 years, to reach $1.2 trillion until 2036. So it's a once in a lifetime value creation opportunity. And from our experience, it's now all about the how to get faster to market, how to become more cost efficient in terms of creating these features. And I think the collaboration across the ecosystem, I think, is the key success factor to actually do it. And we also have learned it because we are also a software tier 1. Not everyone knows it, but we are a software tier 1. And working with the co-panelists, and we have learn that if you contribute your assets, if you contribute your software specs to more open source standards, to creating tool chains that enables a seamless collaboration across the ecosystem, the potential is huge. So we have found out also in our collaboration with Google, for instance, that on certain development steps, we are not talking about an improvement of 10%, we are talking about an improvement of factor 10, right? In terms of being faster. There's an opportunity of cost reduction of more than 30%, especially with the potential of AI, for instance. So the opportunity is huge, and I'm looking forward to the conversation on this panel. So thanks very much for having us.
Thank you, Jürgen, for setting this up. And like you said, this is $1 trillion opportunity for the automotive industry. And I'd like to start my first question to Steve. How is Google enabling agility in the SDV stack through cloud-native DevOps, CI, CD, and AI? And how does Google Horizon showcase this impact?
Yeah, well, thank you first of all for having us here. It's a great conversation. I think when people talk about SDVs, it's not just the vehicle, it's really the whole ecosystem around the vehicle that is important. So, I mean, for example, what's the point of having an SDV vehicle if you can only update it once or twice a year? Then it's not really a software-defined vehicle. So for us at Google, we want to contribute by really focusing on the tool chains and the platforms that help our customers accelerate their development. That's why we built and partnered with Accenture to build our Horizon platform. And it's kind of really focusing in two key areas. Number one is an automotive-grade, open-source, cloud-based tool chain. That helps the software developers globally work together in a seamless way. It helps our customers scale their testing, their build cycles, to thousands of instances, so they can really kind of enable their engineers to be more effective. and it's an open source platform. So we can have partners like Electrobit and other partners come in and contribute to the tool chain. So it's not just bound by what Google does, it's really like what the OEM needs. So that's one. And then the second part is really the AI piece. Everyone's talking about AI, but for us at Google, that's our DNA. That's what we do. And it's like AI in the coding piece, in the testing, creating, test scripts, automating test scripts, in the build phase. So we have AI embedded at each step in the Horizon platform, and I think that's going to further enhance kind of the engineers in the future.
Thank you so much, Steve. My next question to Dipti. Dipti, how is ARM helping power next-gen vehicles through scalable, energy-efficient computer and abstraction?
Well, you actually answered some of my questions and the question. Scalability, energy efficient, those things are fundamental. They're fundamental table stakes in what we're trying to do with automotive, mobility, and more importantly, SDV. So from the standpoint of scalability, ARM's technology scales from the lowest power compute to data center-like compute. We have a portfolio of automotive enhanced products, which is safety critical applications, ASLB, ASLD certified, pre-certified IP, so we take into safety into account when we develop our IP. We also have subsystems where we put IP together to make it easier for the silicon ecosystem to create silicon for this space. So all of those elements are necessary to have a robust ecosystem of hardware and software. Let's talk about software for a moment. ARM has a platform called SOFI, an open source consortium where we work with the entire industry. We have over 150 members of this consortium where we pull together a standard way to interact at the edge, a standard interface so software can be deployed on the endpoints. And then the secret sauce to this is what Steve said, which is it's not just about the car, it's a full solution data center to edge. It's no use if you have a software-defined vehicle. If you can't verify that software, validate that software, develop that software in the cloud, which ARM IP is in the cloud, as well as in the car. So when you have the same exact consistent architecture, cloud to endpoint, it makes everything much easier to be able to deploy securely and safely. And then our partners take advantage of that to create these incredible platforms like the one we have here with Google in order to be able to deploy faster and scale. So across the entire value chain.
Fantastic. And Jürgen, did you want to add something?
No, actually, I would like to add to what Steve has said also, in terms of the importance of AI, right? I mean, for us, AI is a key element in terms of really reinventing the way we work on user-centric vehicles and also what we can offer to the user in terms of, we said, it's an integration of new technology and human ingenuity in terms of really thinking about, we call it augmented AI, not just improving an existing process by using co-pilots, but really building a new process around AI, right? With the humans, with the engineers. And also what we can do with AI, augmenting the assistance. We see already many vehicles to use the full capability of context data, vehicle sensors, external data, the user data, to really, bring something much more meaningful to the user than any smartphone can do if you leverage the full impact. So that's what I think is very important to us. Thank you.
And I would go so far as to say that the software-defined environment is fundamental to be able to deploy AI. So when we started talking about AI-defined vehicles and all these capabilities, at the end of the day, the point that's so important here is that it's user. It's the consumer that's demanding these things, right? And this is where the consumer gets the value. But fundamentally, software-defined is the basis to which we can grow and create these AI-defined vehicles.
I'd like to switch into a new topic about standardization versus differentiation in a question for Jeff. Jeff, how can in-vehicle orchestration platforms enable both reusable architecture and OEM-specific innovation?
Well, thanks for having me. This is a topic very near and dear to my heart. So I think if you look at traditional in-vehicle applications, they've always been vertically designed and implemented, which means they are tightly coupled to the hardware and they're very siloed, so they don't share a lot of functions, which means if anything changes in the vehicle, you need to change the app. An orchestration platform, and by the way, some people call it a vehicle operating system, but it's pretty much one and the same in terms of terminology, is horizontally architected and implemented, which means it's across all of the hardware, it's across different EE architectures. Job one of an orchestration platform is to abstract all of the hardware, software, topology complexities away from the application. That means your apps are more reusable, they're portable. You can apply them to different EE architectures and different vehicle models. The second job of an orchestration platform is to provide infrastructure services. And what are these services? Well, there's connectivity services like in-vehicle network management, prioritization, failover, connectivity to the cloud. There's data services. How do you access the data? How do you manage it? How do you process it? How do you transmit it? There's security services, authentication, authorization, intrusion detection. There's runtime environment services for deploying AI models, for example, or many other applications, and how do you connect it to other systems in the vehicle? That's critical for running AI in the vehicle. And how do you prioritize and how do you schedule? So if you look at all of these services, and they're a rich set, they should be provided to every application in the vehicle. So that when an application wants a function, it's there on demand. And with that model, then now you can develop an application without worrying about everything that should be there for you, which means that an OEM can develop an application very quickly. They can be lighter weight, they're easier to update, they're more leverageable, and they can bring their innovation to market much, much quicker. The other thing that it obviously does is OEMs can now focus on what's really important to their business, and that is creating new value for their customers and differentiation for their products.
Fantastic, thank you, Jeff. And Stefan, all of this leads right to where you are in this value chain. And my question for you is, in your role driving BMW's connected technologies and digital platforms, how do you determine which software capabilities should be standardized across the platforms for efficiency, and which must remain proprietary to preserve and enhance the BMW brand experience?
If you take a look at our product, and I think our product is a real software-defined vehicle, so we have taken a look in our complete architecture, and we're trying to abstract as much as possible to really to focus on a single application. So we have one approach, what we call internally a one-app approach. So I have one application which is running through on different generation, different cars all at the same time. So if we have one software branch where we can really serve our complete fleet, what we're doing actually today. And the tricky part right now, there's a lot of discussion. We do all our software by ourselves. I think that's not a good idea. I think the only thing you have to do is you have to have a clear understanding of your architecture. You have to define it by yourself. And then you go bit by piece through your complete architecture and decide, is this a product which is differentiating? Is this a product I can get as an open source product? Can I get a license for it, or can I co-develop it with a partner? And at the end of the day, there's only a little left where you can say, okay, this is not available on the market, or it's really differentiated, then you build it by your own. And this is actually how we put at every piece of software and every module in our structure. We always have a constant process of looking at it, if it's still valid to do it by yourself, or is there actually an offering on the market, or is there an application we're building already a commodity, so we don't have to differentiate anymore, and then we use a commodity at the same time. This gives you certainly much more speed, access to a bigger ecosystem. And just to give you an example, one thing what we always want to do by ourselves is our user interface, because this is a part of our brand. We want to differentiate, and if you take a look at our platform today, the same platform we are building in BMW is running in a Mini as well, and Rolls-Royce as well. And we're doing this just by exchanging the user interface to this. So looking at every bits and piece, understanding the architecture and picking the right one, I think it's the best recipe to do so.
Could I ask one question? When you were going and looking at the Neue Klasse, and you were going us, them, us, them, us, them, how many decisions did you have? Was it 100? Or when it comes to picking software versus you do it, they do it? Maybe you don't know the number, but I just...
To be honest, the interesting thing is, over the sake of time, we took a decision, and actually we changed a couple of decisions over the time as well, because they were also offering on the market. So I would say it's a continuous process. It's more than 100 decisions, because it's a lot of different modules and a lot of different software bits and pieces. And especially on the application layer, 6 months ago we just decided to integrate additional services which were not existing at the point in time when we designed the platform. So it's a really ongoing process all the time, and we have a pretty close look on everything what we are doing and thinking, is it the right way to do it like this or the other way?
Fantastic, thanks for that extra insight. And Steve, a lot of those then decisions are heading your way. How can vehicle data and contextual intelligence create value for users and ecosystems? And how does Google see AI-powered SDVs?
Yeah, maybe this is more of a question for Stefan, but I'll try answering.
Okay.
I think, so there's two questions. One is like data, and the other one is around the AI vehicle. If you start looking at data is the core to everything. I mean, without the context, these services are not going to work. So the ability to have vehicle context as well as the user's context is really important. So I'll give you an example. The simple thing about like switching on your car's air conditioning or heating, depending on if you live in a hot or cold climate, that's a normal use case. But how many times have people walked up to their car on a hot day and the car's not been switched on because you just forget to switch it on? By having the context of the vehicle, knowing what the temperature is inside, and then having the context of the user through their companion apps, knowing where they are. So if they go to a shopping mall, as they're walking back to the car, for the car and the intelligence and the cloud to be able to know that the user is walking back, to be automatically able to switch on the air conditioning or because they know of the context of the vehicle, that's just all done through data, right? So these are the type of experiences that you can start building. But if I now talk about AI and like how AI is going to help transform, you take that same example and imagine that I'm walking up to the car with shopping bags in my hands and the cameras can pick that up, and instead of opening the front door, it opens the trunk automatically when I arrive. That's where the power of AI is going to take a simple use case and make it 10 times better. And to me, that's like kind of where that sits, but I don't know, Stefan, maybe you could.
There are actually a ton of use cases you can do, and especially if you have a contextual understanding of your environment. And just let me give you a completely different example, and a super obvious one. We figured out that a lot of people, when they are charging their car, the position where they are charging is a different one than the position which is actually marked on the map. Because right now the mapping of the charging station is not really good. So if you're a simple AI algorithm running all the time in the back, you may only check the GPS position of the car, the GPS position of the charging station, if it's plugged in or not. And we just corrected it instantly, right at the moment when it's going to happen. And this is the small things you really can accelerate and increase the service for our customer. It's a small thing, but at any point in time, it gives you really a lot of excitement.
Keeping that same theme going, Stefan, where does BMW see the biggest opportunities for AI to enhance the in-car experience and really lead to monetary value?
I just gave you an example, and on the other hand, we have in the car context so much knowledge about the cars itself. So we really can start, for example, on the service side. We know exactly the status of your car, so we can give you a recommendation if it might be a good time to change your tires before you get a flat, for example. We are monitoring actually with our backend infrastructure the status of your battery and get a better understanding about your battery health and about your charging behavior. So actually, it's for the customer itself, it's a great benefit because the cost of service is getting down, and we get a recommendation at the right point in time. This is why more on the service side. And on the other hand, certainly if you're talking about interaction with the car, about large language model and speech interaction, we certainly can give our customer a complete different experience when interacting with the product. So there's a million opportunities, and I could talk about this for hours, what kind of ideas we're having. We're being together, have a lot of discussion what we can do. It's always finding some bits of pieces in the data and just improving it, and it's often the small things. When you're driving to a charging station, we recognize this, and when you get outside the car, we are opening the charging flap for you. And if you're leaving, we're just closing it. Now you can say, is it necessary or not? However, that's a small magic, your product is really smart in doing the right thing at the right point in time.
And next level safety and convenience, which is fantastic.
And with the knowledge about what's happening in the car and about the user, I think, and also combining this with the opportunity to permanently update and upgrade the car, you also can find out what's really value to the user and also sell features during the user life cycle, right? I mean, this is what we have to find, for instance, when we talk about this value opportunity, because, features on demand so far is still quite difficult because you need to really understand what the user values and how to offer these new features. But, in the new world, I think there's an opportunity, right?
If you take a look at our product, we have more than 10 million plus cars where we exactly know what our customers are doing in the car. In the automotive industry, quite usual. I think in the mobile industry, it's standard. So we have a pretty good understanding what kind of features are getting used, what are used in what kind of context and what kind of use cases. So it's a constant possibility to optimize. And there's often a lot of legend what people are doing in the car and what they are not. Now there are the real numbers to prove it and to say, okay, they use this feature in this context, or maybe this one they never use, and makes it too complicated, let's get rid of it. So sunsetting features is an interesting thing as well, but we do this quite often.
And Jürgen, this is a great time to ask you, what's next now that Gen AI is in the vehicle, and what's beyond in-car content?
No, I think that we heard already a lot of great use cases, and I think there are great examples of getting into the next era. We've seen a lot of voice assistants, we've seen large language models, and they can already add a lot of user value, right? But when you can integrate certain data points, and Steve, you mentioned the importance of data, I can only echo that. This is one of the key success factors from our point of view. You can only generate the value if you have the data sets, if you have the data architectures in place, right? And if you can have access to different data sets, you can also use AI agents. So go far beyond large language models, but use agentic AI to really put these different data points together in an intelligent way. And I think that's what we see right now, and where I think there's a lot of potential that can be untapped in the next years. And the technology is there, so I think you just need to implement it at speed, at scale, at cost.
And let me add to that, to complement what you're saying. You talked about in-vehicle. Also think about the AI technology that's necessary to drive the vehicle. And we've talked about fully autonomous vehicles. We'll back away from fully autonomous for a moment. Just more autonomous features to help the driver safely, or identify when the driver may be sleepy, right? There could be a camera, you could tell if the driver's sleepy. So there's so many, the possibilities are endless when you start opening this up. And from a compute standpoint, it's a really interesting, fun time, because when we start doing all of this, you start putting really, really critical, functionally safe compute. We call it functionally safe compute next to, putting a mustache on a face, which, I don't care if I mess it up, right? But you start to do these things, and they're all integrated into one box. How do we separate all of this? How do we make sure the data stays private, right? Those are the kind of things we have to worry about before they're even ready to start implementing that in our architectural level.
I'd like to add to this. And the beauty of all this, we started out as an SDV discussion, but we did definitely, I think we all believe that AI and SDV are one and the same.
Yep.
You have to have AI in every vehicle, and in order to have AI, you have to have SDV.
Mm-hmm.
So AI is a pillar of SDV, SDV is a pillar of AI, and they're one and the same in my opinion. So to add to some of your points, AI is just beginning in the vehicle. I don't think, today we think of AI as autonomous vehicles and ADAS, but there's so many other opportunities for AI to add, like vehicle optimization or component optimization or anomaly detection or increasing that vehicle to driver experience and relationship. So we see that we're just beginning to scratch the surface. It's almost a nascent market that's about to explode.
And we've all brushed against this particular topic a little bit today. I'd also like to talk a little bit about cybersecurity. We've all talked about security because one of the only breaks that could hurt this pathway towards SDVs and autonomous is if we have some cybersecurity situations with the cars taken over. And I know all of you are working to make sure that this never happens. How far are we from having just a situation where you just say it's security? Almost like you know the seatbelt is going to work, the cybersecurity in the cars are going to work.
I'll jump in. I will answer in a controversial way just for the sake of argument.
Okay.
I will never get there because this is the whole point of what we're doing. It's software defined, and as soon as we think we're secure, there'll be something else, I guarantee. This is your world, I'm sure you live in it, right? There'll be something else, and that is the whole point of the conversation. I think it brings it all, it's a great question because it brings it all back. The fact that we are a software defined vehicle, we can update and we can always be up to date on the greatest and greatest techniques available to us. And that, I believe, will not stop. They'll get smarter and we'll get smarter.
Because like you said, there's always going to be the case that nobody has ever thought of in a million years. Okay.
It's one of those things you can't run yourself out of a job, right? It's not, you try, but you can't.
Exactly.
I mean, I totally agree with that. I mean, it's always going to be a cat and mouse game. So the more functionality you add in a vehicle, whether it's software or hardware, the more vulnerabilities and points of attack you'll have. But certainly the solution isn't to go backwards, it's to go forwards. And I think this is where collaboration in the ecosystem is very important because you have great security companies out there that don't do anything except security. So you should collaborate with them to help bolster your security in your vehicles.
I'd like to have another question for the entire panel. You can all answer it in order here, but the question is, from your vantage point, what will define successful collaboration? Point you just made, Jeff, and competitive edge in this new era of software-defined mobility. What will it take to make SDVs a reality? And Dipti, I'd like to have you be the first to take on this question.
Well, thanks. I think it's no one company can do this alone. You asked a very insightful question earlier, which was around differentiation versus standardization, and that's a very important concept that we think about. Quite often, ARM is a standard compute platform, and we work to standardize certain base aspects. Security is one of them, safety is another one across the ecosystem. Another area we standardize is how software sits on top of compute and how we interface to the cloud. But then, so standards are important to enable scale. Standards are important to create ecosystem because then everybody can work together and expand on those standards and create different capabilities. And that security company that focuses on security can deploy their solution on any product, and we get the latest and greatest because there's some standardization on deployment points. But allowing that security company to do what they do best, which is security, is important too. So that's the differentiation angle. And I think, again, no one company can do this alone. You've got some of the best companies in the world sitting here with you, and they're all saying the same thing, which is we have to work together. We alone cannot do this, and I think that's a good balance of standardization, of differentiation, and thinking thoughtfully about that.
Great point. And Jeff, what do you think? What will it take to make SDVs a reality?
I think the way you define success here is if we go back to the original point of SDV, it's allowing and enabling OEMs to innovate faster. It's to bring their new applications, their new innovations, create customer value and differentiate their own product as fast as possible. And to do that requires collaboration. And I think what they need to do is figure out how to leverage solutions that may already be there. Of course, there's always going to be a debate in terms of Do we leverage our internally developed solutions, or do we leverage partner solutions? And I think the answer is going to be different from OEM to OEM and supplier to supplier. But I think the companies that will win will be the companies that figure out what's best for them and what's that right mix of collaboration and leveraging solutions that may be in-house versus not. And those are the companies that I think that will innovate faster and bring their value to market.
And Steve, what do you see as the key, that competitive edge that can be brought?
I think it's interesting. Like 5 years ago, I probably wouldn't be on the stage, and I probably wouldn't be at NGIFTY, right? Like we probably wouldn't be on stage here together, and we probably wouldn't have been at this event. That just goes to show you how the world has shifted, and unfortunately for Stefan, the world's probably become more complex, or better, whichever way you look at it. But I think it is a partnership. I think at the end of the day, there are companies that excel in certain areas, and I think the fact that we're on this stage together just demonstrates that for the automotive customers, like they have to work with the best partners to build the best solution. And when it comes to SDVs, they're not going to be able to succeed by themselves. I mean, I come from the automotive industry as well. There was a time when we tried to build everything ourselves. It makes me cringe when I think about it, but that was the fact. And I think there's been a harsh lessons learned. But what's happening today and what BMW have achieved is amazing. I think it shows you where the future is going.
Yeah, and that's a perfect parlay to Stefan, because you remember those years, Stefan, when you guys were, I mean, again, every single wheel you had to create on your own, and now you're working with partners. How do you see the collaborations developing, and what will it take to make the SDVs reality from BMW's perspective? You guys already say the iX3 is an SDV.
Exactly, yeah. You know, maybe let's take a look at the mechanical world. You know, car development is always integration work. And this is actually what we're good at the car industry, because actually you're building a highly complex product with a lot of different technology. So on the mechanical side, we do this for a long time. Why should we do this the same thing on the software side? So at the end of the day, for me, it's really an integration task. It's really integrating great idea, great products from a lot of different players on the market to one product. So the integration task is ours, but the innovation and the great products out there we have to find and have to integrate. So this is only an integration task. And Steve, like you said, we are super happy that we right now have so many partners with such great technology. We actually can integrate and can use it to enhance our product, because on our own it was not possible at all. You know, I need really great technology, and there is so much room to differentiate and to put a specific BMW flavor on top of it. I don't want to have to do it by myself. So, and especially in the car industry, there was a lot of thinking about, you know, exclusivity. You know, I'm the only one with this feature. I don't believe in this at all. At the end of the day, the only thing I'm interested in is in scalable solution, because in the software world, it only works when it's scalable, because then it's maintainable and then it will last a longer time. Because if not, it's just a one-day hit and then it's gone. And your car is sitting a little bit longer in their garage than only a couple of days. So it's really about the integration task, and working together with the partners.
Okay.
And the shifted mindset, you know, I do agree, Stefan, and maybe the competitive pressure over the last years mounting, and also the huge transformation this industry is going through was also helpful to this, right? So to really trigger a change in mindset, and I think that's what we are seeing, and Steve, you also want to do that, right? And the value story. I think we are coming now also to realize, and we can also see this in the numbers, it does not make sense for every player in this business to create its own microcontroller architecture, for instance, right? And seeing the value and having the mindset, the change in mindset to also execute on it, I think it's now really showing the results that we're currently seeing.
I didn't pay you to say that. Joking. Yeah, right. The custom microcontroller design, but I think it's a good. Yes, I don't think everyone needs to make their own microcontroller design, but at the same time, I think it's important that in all of this, it's an open architecture, and let me explain to you what I mean by when I say open, because it can mean a lot of things. It's easy to fall into these walled gardens where you don't have flexibility and you don't have the ability to move. And the competitive environment for the OEMs today is such that they have to have the independence and the ability to move at their own speed and with their own brand and the brand awareness that comes with that. And there's a lot of ways that just have to be careful and not creating that walled garden or getting yourself walked into one of those. And we spend a lot of time on this, right? It's that discussion. There's these complex discussions about scalability, differentiation versus standardization, and also openness versus a vertical solution. How do I make sure that I get the best of both worlds? And those are the kind of very complex, thoughtful decisions that have to be made when we deploy these things at scale.
And I am unapologetically a journalist. So I have the folks drawing the map to SDVs. I have to ask you, and each one of you, you're on the spot now. When will there be a change and we will just basically call these next generation cars, we will lose the term SDV and there will be more SDVs on the road than the cars that we know today? And Steve, since you're closest to me, I will fry you first. Because we haven't talked about a time frame, and like I said, sorry, I'm a journalist. We've got a lot of people here. I'd love to hear from the fact that you guys know where we're going.
You asked the question, when can we just call a car? Well, I mean, you can do that today.
Okay.
Waymos are on the road. It's a big plug for my company. But anyway, Waymos are on the road, and you can call a car. The technology is there, it's coming. And I don't think the future is that far off in terms of being able to ask for cars to come to you. So I think that is it's still there's a lot of complex hurdles to overcome in terms of personal vehicles, but in terms of like taxis, I think that world is coming faster than we think. In terms of when will we have more SDVs than not, I think we're on, like, if you look at what BMW has created, that is like a world-class leading SDV vehicle. It is. And so we are here. I think the world, we are at that place in time where customers are going to buy vehicles and they're going to continue to see updates, they're going to see improvements. So I don't think it's a matter of when, I think it's here today. That's my personal opinion, and I think you're going to see this come and accelerate very quickly.
Okay, so they're out of the starting gates, Jeff. What is your thought on this?
I might have a slightly different opinion.
Okay.
I think SDVs, that terminology will continue to evolve and change. I think one of the exciting things about this period of time is the rapid, introduction of new innovation. And we call SDVs a platform for innovation because what it really means is we don't know what's going to happen. We don't know what's going to come. And if you build an SDV properly, then the next generation will be able to create new applications and new business models and new AI applications that we don't even dream of today. So I think the puck is going to keep moving. One example I'll give you is when we created a software-defined data center back in the early 2000s, nobody predicted social media. And that's upended an entire industry. Nobody predicted Bitcoin or cryptocurrency, and that upended, financial fintech. So what's going to happen with SDVs and vehicles? I have no idea. There'll be smarter people than I coming up with new use cases and new innovation. So I think the puck is going to continue to move, and it's very difficult to say where it's going to be 10, 20, 50 years from now. So I think it's going to be a wild ride, and I'm certainly I feel very privileged to be part of it.
Dipti, what is your thought on when we'll have more SDVs on the road than non-SDVs?
Can I say I agree with both of them? I do. Okay, let's take the most fundamental definition of a software-defined vehicle. It is a vehicle that has software deployed on the fly, where it could be when it's parked or whether it's on the road. My car, when I park it to charge, it knows, and I can set the time to where the software is deployed. So let's use that as the fundamental definition of being able to update the software in real time. That's the definition. Today, with that definition, I think we're there. I think we're there, and I would agree absolutely. Look at the deployment of BMW. Look at deployment at Mercedes. They are software-defined. And I also think that software-defined vehicles are survival for the OEMs. There's so much software that has to be deployed on this vehicle that to have it perfected the day it walks out the door and have all the features known, I mean, it's a really hard problem to solve. And so this ability to be able to deploy more features as you learn is actually fundamental to surviving in this competitive environment. And then the next generation is the AI-defined vehicle, right? That's what we'll be talking about 2 years from now. So that's the challenge. We have a panel here on AI-defined
Exactly.
vehicles.
2027, come here for the AI.
I think I've already set it up. Let's go.
And Stefan, again, Neue Klasse is your starting point, and you've got 40 models planned from that with those technology underpinnings.
So now, if I give you the proper BMW answer, we started with the connected vehicle. So if you take a look, we have 24 million connected cars right now in the market, which are talking to our backend. So this was the first definition, I would say. You mentioned that the definition, if the car is updatable over the air. We have more than 10 million updatable cars already in the field right now. So it's not like Neue Klasse is a starting point. We have, like I said, 10 million plus vehicle out there we can update over the air, from combustion engine, electric engine, with all the combustion. And now we're launching the Neue Klasse with the next step. So maybe we should start talking about the AI-driven car, and maybe SDV is already old, I'm not really sure. It's a little bit like I like the picture from the puck. It's going somewhere, and it's a little bit like in ice hockey. You have to skate where the puck is going and where it is. So this is literally the game we're in right now.
Very good point. And Jürgen, your perspective?
I think the capability is there, I do agree. I think it's going to be a transformation journey, and to get to really the full potential of AI, software-driven cars, user-centric cars, however you want to call them, I think will keep us busy probably for the next decade.
Fantastic. Well, ladies and gentlemen, take a picture of this panel, exclude me, because these are the pioneers.